Okay, in section 3.2 we're going to be doing some problem solving or applications or word problems, and in order to be able to handle them, of course, you need to do plenty of practice. So you want to read the book and do those examples and watch the videos online, and then also take these suggestions that I give you and have lots of patience and don't get frustrated. So suggestions are that first, of course, read the problem as many times as is needed until it kind of makes sense to you. Sometimes the first time or the second time around you have no clue what it's asking. And then I suggest always you let x or whatever variable you would like, let that be your unknown. And usually it's asked at the end of the problem. And let it be the unknown that all others depend on. In other words, if the problem is talking about Sam's age and then John's age is 2 years older than Sam's age, you probably want to let x be Sam's age so that John's age can be x plus 2. When we do the examples, you'll see what I mean. Step 3 is the hardest one. It's to come up with an equation that relates all the info, and here you might want to remember some of the known formulas. They might be to your advantage, so that's the hard step, to connect everything together. And then once you have that, solve the equation and check to make sure things make sense. And normally if x was, for example, you let it be Sam's age and you found x to be -5, you should go check your work, because it wouldn't make sense for an age to be negative. So these are my suggestions. Let's go practice and review some basics that you should know. So this is some translations that we want to practice before we get to the actual word problems. Let's say you're asked for 3 more than a number, and here I'm just going to use x for my variable every time there's an unknown. It says 3 more than a number. Well, if I translate that, the number, I let it be the unknown x every time, that would be 3 plus x or x plus 3, because the order in which you add doesn't matter. Next one says twice a number, so if we translate that into a mathematical symbol, that would just be 2 times a number, twice a number. Next one says twice, it's hard to read, a number over here, and this one is more than, 3 more than. So it says 3 more than twice a number, and if we translate that into a mathematical symbol, it'd be 3 more than twice a number. Or again, since the order in which we add doesn't matter, okay, 3 less than a number. If I say 2 less than 5, you would think of the number 3. So 3 less than a number would be x minus 3, and the order matters here. So it can't be 3 minus x, it has to be x minus 3. Again, if I say 2 less than 5, the answer would be 3, or 2 less than 10, the answer would be 8. What you do is you take the second number and you subtract the first from it. 3 less than a number is x minus 3. The next one has the keyword the sum of a number and 2. Sum means add, so that would be x plus 3 or 3 plus x. It's the sum of blank and blank. Just take the 2 pieces and add them. Next keyword, the difference of twice a number and 3. And again, for subtraction, the order matters, so in the order that it is, twice a number and 3. And you look at their difference, the difference of twice a number and 3. Next keyword, the product of a number and 3. Product means multiply, so the product of a number and 3 would really just be 3 times x, or 3x. The quotient of 3 times a number and 10. So the quotient of these two things, 3 times a number is 3x, and quotient means division. The second item is 10. So the quotient of 3x and 10 is what we're looking at. Next we have 5% of a number. So number 5% means per 100. So we're really looking at something like 5 divided by 100, which moves this invisible decimal at the end twice to the left, because 5 divided by 100 is 0.05. So 5% of a number is 0.05 times x. Similarly, 20% of a number is really 20 over 100, which is 0.20, is 0.20 times x, or just 0.2x, because the 0 after the 2 doesn't really mean anything. So 20% of a number. Next one, 100% of a number. Well, 100% is just 100 over 100, which is just 1. So it's really 1 times x, or just x. That would be 100% of a number, or all of the number that is in its entirety, which would just be the number itself, x. 3 subtracted from a number. So 3 subtracted from a number, the number has to come first, and then you take away 3 from it. 3 subtracted from a number. The sum, another keyword, of 3 consecutive integers. Well, consecutive means one right after another. So if I give you the integer 3, the next one would be 4, the next one would be 5, and so forth. So each time to get from one to the next consecutive integer, all you're doing is adding 1 to the previous one. So if I'm looking at 3 consecutive integers, I would call maybe the first one just x, and then the next one would be 1 bigger than it, so that would be x plus 1. That's the second integer. And then the third one would just be 1 bigger than the previous one, so x plus 1 plus another 1 would be x plus 2, and there I have my 3 integers. And since it says the sum, I take the first one, add to it the second one. Again, I'm putting some dotted in parentheses, because when you're adding, parentheses really can be dropped if you want. So I have 3 items, first integer, second, and third, and their sum, if I were to simplify it, would give me 1, 2, 3 x's, plus 1 and 2 gives me 3. So the sum of 3 consecutive integers would be that, and this would be the simplified version of it, 3x plus 3. Some formulas we need for this section. If you have a rectangle, the perimeter, which is the distance all the way around this thing, is 2 L's added and 2 W's added. The area, which is what you would need to fill the inside of it, is length times width. For a circle, the perimeter is called the circumference, so distance all the way around would be 2 pi r, and for pi, you can use the approximate of 3.14, but your calculator has a pi button, most likely your scientific or graphing calculator, so use that. That way you have less round-off error because you're not truncating all the other digits. And the area to fill the circle inside is pi r squared. For a triangle, the perimeter again is distance all around, so just add the sides, a plus b plus c. The area to fill inside is half of base times the altitude or the height. Investment at simple interest, you might remember the formula I equals PRT. This is the interest in dollars that you either owe or you make. This is the principal, which is basically the money that you put in or you take out as a loan. R is the interest rate, and you always want to put it in decimal form when you use it in the formula. So I'll put decimal form as a note. And then T is the time, usually in years, because the interest rate is given to you per year. So we'll be using that with examples as well. For motion problems, you want to remember D equals RT, where D stands for the distance, R stands for the average rate or speed, and T stands for time. And you want your units to match up. So if the distance is in miles and the time is in hours, your rate will be in miles per hour. Or if the distance is given to you in minutes and the rate is given to you in miles per hour, you want to convert the time to hours so that your distance can pop out in miles.